My name is Rick Powers. People in the patch call me Ricky Bobby. I will be your trusted guide today in comic relief. The trailer you see before you was originally a 52-foot reefer trailer, and by the grace of God and a lot of hard work by some great teams, we were able to, in about 3 weeks' time, turn it into the live training trailer you see today. It took a village, a lot of hard work by a lot of guys. I'm really happy. But you're seeing it day one. This is the first time we've ever taken it out. So its whole concept and mission is to take the training to the next level and do live practical training rather than classroom. Classroom has its place and it must be there, but to give them hands-on training, practical application, and start building muscle memory, especially for green hats, SSEs that are coming in that have never had exposure to, lockout, tag out. We've got a quick disconnect here for air that we can actually pressure this up with air and teach them the proper ways to isolate and blow down, double check and make sure. We've got the fall arrest, which you're going to see. My good friend Glenn here is going to put on a wonderful presentation about fall arrest and using the tripod up there. And then Aaron and his team are going to do a presentation about confined space, ventilation, talking through those hazards and the way they mitigate it with their equipment. Today, with the confined space, I'm going to hand it off to Mr. Glenn Yamada, and he's going to take you through the fall arrest portion of that. Mr. Yamada?
Thank you. Well, let's talk about this. What are the things you have to consider when you're dealing with a permit required confined space? One, atmosphere, right? You're going to monitor your atmosphere. So that's where you're going to use your gas detection. Two, ventilation of the confined space. Three, lockout, tag out. Do I have everything shut off? Four, and probably most importantly, communication. You got to be able to communicate. If you enter a confined space, okay, you have to have an attendant up there, and if it's permit required, you want to be able to communicate. Why? If I go into a tank and it's void of oxygen, you know what? I want to know if somebody's up there that can get me out right away, all right? And what are the signs of oxygen deficiency in a workplace atmosphere? The initial signs are going to be kind of like you're drunk. You hear the sound like you're drunk and slurred speech. And then the second reaction would be, and that's why your alarm points on your instruments are set at 19.5. Because you start dropping below that, all of a sudden you almost go brain dead. So you want to have an attendant at the top who's able to make a rescue when they feel like you're going to be either unconscious or unable to climb back out. Now let's talk about that. Climbing out of a tank. Do all the tanks have ladders going down? What's that? Nope. So how does somebody get into one if they're going to clean it? And this is what we find a lot of people do. They say, gosh, we got a tripod. We got a winch on that tripod. You know what? We're just lowering down with that winch, right? No. Those moderated winches are not designed to raise and lower personnel. They're not. They're designed for rescue. All of a sudden you're going, okay, Glenn, but it doesn't make sense. It's got a raise and lower mode on the winch. You know what that's for? Typically, in a confined space rescue or even in recovery, you start cranking somebody out. All of a sudden they get an arm caught or a leg caught. Probability? Could be. You're going to keep cranking. Keep in mind, these winches are designed and they have the strength to literally dislocate an arm or pull, dislocate a leg. So you got to be able to lower them back just a skosh or a little bit to get whatever's hung up released. Now what I'm going to show you up here, and my cohort in crime here, Mark Malaysia, he's going to be the entrant. I'm going to be the attendee. And I'm going to show you folks how to do it properly. If you have those scenarios where you have to lower somebody into a confined space, use a winch in a system that's designed to raise and lower personnel. They're not the same winch though, okay? When you have a rescue winch, do not use that winch to lower somebody down with because you don't have a ladder. There's another winch that you use together with it, and we're going to go through this demonstration. And this is something that not everybody knows. When rescuing personnel with a tripod, you don't crank them all the way up. Don't worry about that. You know what you want to do? Tripods are designed with leg locks at the top. get their butt to where they're just sitting, and they're unconscious, they're hanging off the dorsal D, so you get them up to a height out of the confined space where their butt is right here. Then what you do, you take the tripod, and it's got leg locks, and you tilt it back. Now all of a sudden, what are you doing? You're laying the person back on the walking, working surface. And that's the way they're designed. However, it's not a perfect world out there. So for those imperfect situations where you can't use a tripod, we have a device inside there in our booth which allows you to use a boom that'll articulate like this. And that boom, you can raise them up and then swing it over and then lower them down. So let's go through this. Always want to use a harness for what we call a sternum D-ring right here, okay? You're going to lower him down with this. This is fall arrest. This is in case that winch fails, this is going to catch him, all right? So this winch right here, you don't use it to raise and lower people with. It's only used for rescue. Now, all of these come with a little tagline like this. Those of you who worked on a rig and have those 130 foot blocks up there, the worst thing you could do is just get off the bottom of that rig and let go. Because what's going to happen is the retraction of this cable up there is going to bird cage, it's going to jam up. So all the manufacturers will provide you with a tagline. Now Mark is in the tank, and you know what? He's going to walk this way, he's going to walk that way. He has to disconnect. He can't stay, it isn't practical for him to stay connected to it like that. So he's going to basically let this retract back and have the tagline like this, all right? This part here is basically, again, the working device, and that's what he's going to use to get it back up with. I'm going to go back up, and if I wanted to, I could raise him back up like this. I don't want to. I don't feel like doing that, but it takes a lot of work to get him back up like that, all right? So that's basically how you want to use the setup. Remember in fall protection, see his leg straps? Right here, you have those two femoral arteries, and those arteries basically are going right to your blood supply, to your heart. So, can Mark be suspended in that harness for any length of time? No. And when I say no, I'm not talking like a half hour. I'm talking maybe 10, 15 minutes max. And eventually what happens is it starts cutting off blood to the heart like that. So, in a situation like that, once he gets down, he disconnects. He's got the line here to get him back up, all right? And now he can go to work, okay? So that's how you're going to use the system.
So my name's Aaron Ford with SuperVac. We have a manufacturing plant here in Fort Collins, not too far away here from Greeley, but we make confined space blowers, non-hazardous and hazardous. We also do PPV blowers that are sold to fire departments, etc. Industrial line, like you saw, there's a fan up on top with that ducting system coming down. It's called our LFR BF duct. It's a ducting that has FR capabilities or properties in it, and as well as anti-static ballistic fiber that runs through it. So we can use it all in the confined space. With that one, we put one bend in it, and we compared it to a competitor of ours that has to use a saddle vent. So climbing through the manhole and able to smash that up against the wall, you let go of that, it goes back to full CFM. So the standard CFM on that is 1037 without any ducting. Once we introduce that ducting into it, we're getting 700 CFM at the bottom of it, compared to a competitor of ours is 350 at the bottom. So we'd also have the capability of using spiral duct that you have in here to do that at the same application. That's an 8-inch fan. We go all the way up into 24-inch fans in the box fan size. So any one of the ductings can be transformed onto the 8-inch fan over to the box fan, just depending on what you want, hazardous location material or not. Okay, so one thing you guys always have to make sure of, any bends that you put into the ducting, if you're using ducting like this, it's going to give you less CFM at the end of the products. Okay, so biggest thing is, do you have permission to go in? Do you have a signed waiver and a confined space? Did you do your protocols and lockout, tagout like you said? Going in and isolating whatever you guys are controlling, whatever gas, shutting off all that stuff and confining it to that one space, getting air in and out if possible, making sure your ventilation is going all the way to the bottom. Sometimes it's a long run, right? So you gotta have to hook up a couple sections of ducts to get down there. With the one that you saw in here, I had it folded up on itself so you can shorten the length of it. So if you have a 6-foot manhole that you have to go in, and that's 15, 20 feet, you can take it up and turn it inside out on itself. Something that you really can't do with that type of ducting, you just have to move it farther out the hole. Biggest thing is to make sure you're not going into any IDLH atmosphere with vapors. So you're testing at the manhole, right? You guys are always testing when you're going in or before you go in. And OSHA, I'm from California, call me weird, everyone does, I get it. People in California are weird. We have weird standards. So in Colorado, I'm not 100% positive of what you guys have to do. But in California, they have some different states that you have to do a certain number of air exchanges, okay? The best rule of thumb that you guys can do is 5 air exchanges before anyone even goes into a confined space. Make sense? So that being said, it may take 10 minutes, it may take 20 minutes, it may take an hour. There's some water and sewer departments that we deal with where we build big trailer mounted fans that they run for 24 hours before they can even let someone go in and clean the sewer out. Okay. Next thing is make sure you have adequate air, 19.5 to 23.5% oxygen, and maintain that. Then you do a test again. You can wear all your gas detection monitors, whatever company you guys are deciding to go with. With this fan, you can actually have the plate on the exhaust side or the non-exhaust side, meaning you can push or pull the negative from the area you guys are trying to clear. Okay, so that's just basically a switch here that we have hooked up. So we're going to have air moving out of that area, and you're going to have to kind of size up your area and do, you know, length times height times width, and get how much volume of air you need to put in that confined space. Last thing, if you have a rescuer up on top, I think it's most critical, like Glenn was saying, is have someone there with another air source or a way of getting you out if something does go haywire.